Have you ever wondered about the quality of your drinking water? How it compares to the lake or pond you live by, or the stream that you fish in? Water is not always equal, and the kind of drinking water that people have can vary greatly. The EPA, or the Environmental Protection Agency, has limits on a variety of parameters, chemicals, ions, etc., that can be found in your drinking water, your local stream, or lake. But if you have a concern about your tap water or local water body, what can you do about it? One option is to use a platform like WaterInsights, an online crowdsourcing water quality testing platform. Using this program, citizen scientists and students can test their various local water resources using water testing strips. The goal of Water Insights is to create a large database of water quality data in order to create better drinking water for all. This award-winning program was founded by a young student, Sahidi Pingali, who was trying to better understand how the foaming lake by where she lived in Bangalore, India, which often caught fire, was polluted. She created the program in order to help the public have access to information, materials, and data needed to tackle their water quality issues and problems. My hope is to get some of these water testing strips into the hands of some of you Connecticut Envirothon students. You can test your tap water, a local water body, stormwater runoff, or rainwater, or even a few of these and compare your data. Your data can contribute to a nationwide water database and can help create baseline data to identify problem locations. Citizen science is a wonderful tool that allows the general public to be involved in monitoring their own natural resources and can create real life change. No matter what job or field you go into in your life, I implore you to be involved in citizen science in the future. To go into more on the strips themselves, these water testing strips have 6 parameters on them: nitrate, nitrite, hardness, chloride, alkalinity, and pH. Each one of the 6 boxes on the strip is a different parameter. The parameters were selected because they are good indicators of a variety of water quality problems. Nitrate and nitrite are nutrients that occur naturally, but can also be a sign of contamination from sources such as fertilizers and septic systems. Hardness is a measure of the concentration of minerals in your water. Depending on the geology or bedrock of your water, you can find iron, calcium, magnesium, and others. Hard water is more common in well water compared to town or city water. And while minerals in your water is not a bad thing, it can be in excess and it can cause buildup of deposits such as lime in your pipes, which can be costly. Chlorine, not to be confused with chloride ions, which are found in salt, chlorine is used to disinfect water from bacteria and pathogens. Allowed to be detected up to 4 parts per million, chlorine is used more often in city or town water compared to well water, but it can create a variety of dangerous byproducts in your drinking water. Thus, an excess beyond the allowed limits can be dangerous. Alkalinity is how water can neutralize acid or the baseness of your water. Typically, hardness and alkalinity are equal to each other, and when they are not, that can be an indication of a contamination source, or that your water has been processed in some way, such as through a softener. Lastly, pH, or the concentration of hydrogen ions, H plus ions, can indicate a variety of water quality problems. There is an acceptable range of pH between 6.5 and 8.5. Pure water typically has a neutral pH of 7. I wanted to test these water strips out myself, so I took a few samples in the Lake Warmaaug watershed, including 2 samples from the major tributary or river of Lake Warmaaug, Sucker Brook. One sample was taken right before Sucker Brook enters the lake, and the other was taken at the top of the watershed or the headwaters. The goal of this was to see how the water changes throughout its time in the river, what additional nutrients, chemicals, etc. were added to the river. I also took a sample right in the lake itself and a water sample from a nearby catch basin, which is a structure that catches stormwater runoff from the surrounding roads and sends the water into the closest body of water. I chose this catch basin because, as you can see on screen now, the catch basin collects water from a hilly road that was covered in salt, that green textured material that you can see on the road. Salt in our waterways is becoming an extreme problem. I will link in the description an interesting story map that goes into this in more detail. Lastly, I sampled the tap water in my home and snowmelt from outside my house. To collect these samples, I made sure to use clean labeled containers and rinse the jar out at least 3 times with the water I was sampling. I tested the strips out in the field, but you can collect them and test them at home as long as it's within an hour of collection time. I dipped the strip into the water I was testing for 1 second and then set a timer for 30 seconds where the strip air dried. Only after 30 seconds did I officially take the data. Over time, these strips will change depending on the air. So it is important not to take the data after 45 seconds, as that no longer represents your water sample. On screen now is a table of all the data that I collected. I won't go into a full analysis here, but I wanted to highlight a few interesting points. First, there is some variation among a number of parameters. For pH specifically, my tap water was the most basic sample taken, while the snow was actually very acidic. My tap water was also the most alkaline with a very low hardness. This makes sense because I know my tap water comes from a well and has been processed and has various softeners and filters on it to make it drinkable, and that removes some of the hardness. While having no nitrate and nitrite in any of my samples was great to see, this means there's no obvious pollution taken, it is important to remember that this is just a snapshot of these water resources. If I were to retake some of these samples closer to right after a large storm event, I could find more examples of nitrate indicating higher levels of runoff. The changing seasons is also a factor in what kind of data you will get. You can get different levels of pollution running into your water bodies depending on if it is summer, where there's a lot of leaf cover from the trees that absorb water and slows it down, versus fall, where there's no leaves on the trees, which means water runs straight down into your water bodies and there's less to hold on to it and slow it down. There was some variation in the upper to lower river water samples that I took. A couple key notes is that the upper river was actually more acidic compared to the lower river, and that the alkalinity in the headwaters was actually higher compared to the lower area of the river, which means that somewhere along the process, there was a decrease in probably an increase of acids in the water that neutralized that alkalinity capability in the water. I ran an additional test on two of my testing sites using water testing strips from Winter Salt Watch, a program trying to track road salt pollution, which can damage roads and cars, be toxic to aquatic life, and when polluting groundwater, can cause health problems such as increased hypertension. I tested the lower Suckerbrook sample, so the one closest to the lake, and I also tested that catch basin where I saw salt nearby. These strips work differently than the Water Insights ones. You place the strip into about an inch of water where the top half of the test strip is not submerged in the water, only the bottom half is. You then wait for up to 10 minutes for the vertical orange line to run up the test strip. You know the sample is done when that horizontal line at the top of the strip turns black. You can then place your test strip onto their conversion chart, and depending on how far that vertical orange color ran up the strip, that converts to milligrams per liter or ppm, parts per million, of chloride ions in your sample. You can obtain 3 of these test strips for free in using the link provided in the description, and you can give your data to their database to contribute to this great project. Important to note is that I wouldn't most likely use your tap water for this test strip. It's best to do probably a stream or a river or a catch basin. If you proceed with these strips, feel free to email me about them. I would love to compare our data. For my 2 sites, the stream and the catch basin, I received radically different results. The stream was fairly normal at around 30 ppm or milligrams per liter of chloride ions. It ran only about to the 1.4 mark on the test strip. The catch basin, on the other hand, ran past their indicator chart all the way up to the 9 on their test strip. This indicates a chloride level of above 618 milligrams per liter of chloride. For reference, anything above 100 milligrams per liter in fresh water is believed to have adverse effects on aquatic life, and drinking water above 250 milligrams per liter will have a salty taste. Moving forward with this data, I will increase the monitoring on that catch basin to get a more robust data set, and will probably send samples out to a lab to get more concrete numbers. But I will also go forward with contacting the town officials about that catch basin. That road is salted by the town, and there may be a compromise to balance the safety of those who use that road and the impact that the road is having on the nearby water body. When using these strips, know that while they are quick and easy to use, there is a trade-off with accuracy. meaning that they're not always 100% accurate. If you get a concerning result on one of your strips, it could be from a contamination or an oversensitivity issue. I recommend using additional strips to verify your data, though you can also email me for additional advice on how to decrease contamination. If we decide that you do actually have a concerning result, I can help you find the correct officials to contact about that and can recommend somewhere where you can get your water officially tested in a lab for more accurate results. Some notes on water testing in the field. Always make sure that you have someone with you when sampling. I will almost never advocate for field work by yourself, no matter who you are. Also, make sure to follow COVID safe procedures while doing your field work. Additionally, you don't know what's in whatever water source you're touching. If it's a stream, etc., it could have high levels of bacteria that you don't know about. So I also recommend washing your hands or using hand sanitizer as soon as you can after doing any water sampling. Always make sure that if you're sampling a water source on private property that you have permission to be there, and make sure you're wearing the right footwear and gear to be safe out in the field. Lastly, always be aware of your surroundings, especially if you're sampling by roads. Make sure at least one person is checking for cars. Your team is interested in having some of these water testing strips sent to you. Please gather how many of you would be interested and have your advisor fill out a Google form that I'm sending to them. As of now, I can provide a few per student if you're interested in trying out multiple sources. Or if you just want to try out your tap water, that's completely fine as well. I will go into how to submit the data to either the app or the website after you have input that you're interested in some of the testing strips. If there's a specific water source that your team is interested in monitoring or you want to learn more about this program, feel free to email me at kelseys@nwc.org and talk more about that. Thank you all so much for your dedication to Envirothon, and feel free to contact me again with any questions or concerns. Thanks for listening.